Welcome to part 8 and the last part of our solution. And so far we had the strategy that we split our group of applicants into a test group and into a select group. And then we memorized the best prints in the test group, the so-called reference prints. And then we took or selected the first prints in the select group that had higher quality than reference prints. And now we want to change our strategy, and instead of memorizing the best prints in the test group, we want to memorize the second best prints or the third best prints or the n best prints. So what we have to do, we have to search in our list test group not the highest number, the best prints, but the second best or third best prints. And therefore here in the first step we create here our list test group. So this is nothing new here. And we print test group. So here we have the random sequence of 50 prints because we have 100 applicants and the size of the test group is 50. And then we set the parameter n best to 2. So we want to select the second best prints here in our test group. And what we have to do, actually we have to sort our list test group in a reverse order. So let's do this here. And there we can see we have sorted our list test group starting from the highest number and ending at the lowest number here. So from 98, 97 until 9, 7 and 6. And now we want to select the second highest number, so here 97, and the second highest number here of our sorted list is at index position 1. So zero-based indexing applies. And if you want to select the second highest number at index position 1, then we have to index here our list for index position 1. And yeah, we have actually our parameter n best is 2. So we have to take here n best minus 1. So let's check this out here. And we get here 97. And now we can also select the third best. So let's put here the parameter n best to 3. So let's check here our sorted test group list. And the third best or the third highest number is 90. And we should get 90 by indexing our list here with n best minus 1. So we get here 2. And at index position 2 of our list is here 90. So this should work. Correct. Alright, and then we can store our n best prints in the variable test group n best. And we can print n best. Alright. So now we have seen and learned how it works, and now we can adjust our princess function, and therefore we copy the code of our princess function. And it's here. And let's paste it here into the cell. And now we have to make only minor adjustments. So first of all, we have to introduce the new parameter n best. And we set the default argument to 1. So by default, we select the best prints in the test group as the reference prints. And then we completely change the line here. So let's copy our code from here. And let's paste it. Now we have here the variable test group n best, and we have to change it also here. And that's it actually. So we actually changed our whole strategy. We can put here for n best all possible numbers. So from 1 to, yeah, in the theory 100. And we only had to make some minor changes here in our function. So this is quite easy actually. So now we can run the cell and define our function. And now we want to check actually the impact of the n best parameter. So we want to compare our strategy where we take the best prints and only the third best prints in the test group as reference prints. And first of all, we want to check the impact on the probability of getting Prince Charming, and therefore we set nbest to 1, and then we iterate over all possible test group sizes, so from 1 until 100. And we store actually all results in the list results first best. And we actually do the same for nbest equals 3, so we create here an empty list, results third best. And then again we iterate over all possible test group sizes, and we have to be careful here, so we iterate over all test group sizes. Then with nbest we have to start with the test group size 3, because selecting the third best prints if we only have a test group size of 1 or 2 doesn't make sense, and we would get here an error. And we actually store all results here in our results lists 3 best. And we take for both simulations here 1000 simulations, and we take here the metric prop best. So let's run both cells here. And we import matplotlib. And now for nbest equals 1 and nbest equals 3, we want to make for both a graph where we have on the x-axis the size of the test group, and on the y-axis the probability of getting Prince Charming. So we have here 2 plots, one with the results first best and one with the results third best, and let's see what we get here. So the green line is here if we select the third best prints in the test group as reference prints, and the blue line here we already know, we take the best prints. And we can see that for all test group sizes, the nbest equals 1 strategy has a higher probability of getting Prince Charming than the nbest equals 3 strategy. So here the blue line completely dominates actually the green line, and if you want to maximize the probability of getting Prince Charming, our strategy should be to select the best prints in the test group as the reference prints. And we could assume that if we increase further here the nbest parameter to 5 or 10, then we get here curves with even lower probabilities, so something like this here or this here. So again, if we want to maximize the probability of getting Prince Charming, then we should select the first best prints in the test group. Alright, so our metric was here the probability of selecting Prince Charming. And now let's move to the metric average. So we compare the average quality of the selected prints with the nbest equals 1 and the nbest equals 3 strategy. And therefore we again iterate over all possible test group sizes, and we save the results in the results lists first best and third best, and then we visualize our results. So let's do this here. So nothing new here. So now we can make our 2 plots. And we actually know already the blue graph here, where we can see the average quality of the selected princes depending on the size of the test group for our strategy nbest equals 1. And we have a maximum here for the blue graph of only about a test group size of 5. And now we can see for our strategy nbest equals 3 that we actually get a completely different line here. So if we have a look here at the green line, then we can see actually that we can maximize the average or the expected quality of the selected princes between a test group size of 20 and 40 about. And we can also see that by moving from the strategy nbest equals 1 to nbest equals 3, we could also increase the maximum of our graph here. So before the maximum of the blue graph was about 90, and here we are significantly over 90. Alright, so now let's compare also the histograms of both strategies. So for both strategies we created 1000 simulations, and now we want to analyze both results lists with 1000 simulations in a histogram. And therefore we take the test group size of 37. Our metric is actually the results lists with all simulations, and we take here the strategies nbest equals 1 and nbest equals 3, and we save our results in the list's results first best and third best. And now we can plot two histograms. So the first histogram with the strategy nbest equals 1 and the second histogram with the strategy nbest equals 3. So let's see what we get here. And first of all, let's cross out here the n equals 3 strategy. So we already know here our blue histogram with the strategy n best equals 1. And we already saw that with this strategy, we have a lot of simulations where we do not select any prince, and we have a lot of simulations where we select Prince Charming. And there's actually a very low frequency here in the middle. And let's cross this out and let's have a look here at our new strategy. Here's a mistake here. It must be n best equals 3 actually. So let's take this again here. And we can see here that the probability of getting no prince at all is actually much lower than before. However, also the probability of getting Prince Charming is much lower. But in exchange, actually we increased the probability of getting the prince with quality 99, 98, 97 and so on. So here actually we reduced the probability of the very extreme cases. And in total, we could here, with this strategy, increase the average quality of the selected prints. So let's again plot both histograms in one graph. So again, here we can see that the strategy nbest equals 1, the probability of the extreme outcomes are larger. However, with our strategy nbest equals 3, we can significantly here reduce the probability of getting no prince, and we increase the probability of getting high quality princes with the quality 90, 91, 92, 98 and so on. And actually here the green strategy in the end gives us a much higher average or expected quality of our selected prince. And let's compare also the average quality of both strategies. So we have a test group size of 37, so we have to change it here. It's not correct. And we can do this visually, so let's go here above. And let's have a look at the test group size of about 37. So we are here, and we can see here that with the strategy nbest equals 3, the average quality of our princes is much higher. So we are here above 90, and with our strategy nbest equals 1, we are here at 65 about. Alright, now we are finished with our Python standard library solution, and I hope you enjoyed it, and I'm looking forward to seeing you also in the NumPy section, where we can hopefully speed up our code and make more advanced analysis, and hopefully we gain more insight on our selection problems. So hope to see you there. Bye!